So we're going to be going over problem number 53 from chapter 14. It reads a spring with the spring constant 15 Newton over meters hangs from the ceiling. A ball is suspended from the spring and is allowed to come to rest. It is then pulled down 6 centimeters and released. If the ball makes 30 oscillations in 20 seconds, what are A, its mass, and then B, the maximum speed? So this is what we know. We know that the spring constant is 15 Newton over meters. We know that our amplitude is 6.0 centimeters. We know that our number is 30 oscillations and that the time that it took was 20 oscillations. So what we can do for trying to find our mass is we can use our equation of our omega squared is equal to our constant divided by our m, which when we rearrange that, we get m equals k, or our constant, divided by our omega squared. Then we can also use our equation that our omega is equal to 2 pi over t, which we can use this t to solve for our this equation right here of our tn. So that's our 20 seconds divided by our number of oscillations equals 30, which simplifies to 2/3, sorry. And then when we plug this t of 2/3 into this equation, it simplifies to our omega equaling 3 pi, which we can then plug in to this and our k constant into this, which when we do our math here, we find that our mass of our ball is equal to 0.17 kilograms. Now for the V max, we can use our equation, two equations actually. One, Vt is equal to our negative V max times our sine omega t plus, my mind just went blank, I can't remember what that sign is. But it's not super important for this problem, so then we can use our second equation, V times t equals negative A omega times sine omega t plus that same symbol again. Which, when we compare these two, we can see that A times so our amplitude times our omega is going to equal V max, and that's what this says right here. And then all we have to do is plug in our omega, 3 pi, times our amplitude, which is 6, to get equal to plug in the math and get our answer to be 56.5 centimeters per second as our V max.